Let me start with
Can I, Mr. Ibrahim, answer?
yes, Ibrahim, you can answer, no problem. Yes, let me click your name. Okay. Read the first question, Ibrahim.
Okay, Mr. Marty is sitting in the sand beside a lake. She noticed that sunlight shining on the lake. Read each sentence that describes how energy from the sun interacts with the substances. Drag each sentence into the correct box. Sunlight bounces off the surface of the lake.
This is one.
Sunlight shines
So, one
on
by
the
one.
beach. Okay.
Sunlight bounces off the surface of the lake. Bounces off. Bounces off. This is reflection or refraction or absorption.
This is reflection.
Bravo, Alex. This is reflection. Thank you, Ibrahim. Let's take the next one. Murtaja.
Yes, teacher.
Read the next sentence.
Marty is which one, teacher?
Sunlight here. From sunlight.
It's the light shines on the beach and transform heat to the sand.
Transfers heat to the sand. Sunlight shines on the beach and transfers heat to the sand. Is it refraction or absorption?
Absorption.
Bravo, Alec. Absorption because it transfers heat to the sand. So that's absorption. And read the last one because it's inevitable.
Waves
So read
of
it.
light are bent as they shine through the water to the lake bottom.
Yes. It went through the water and reached the lake bottom. What is this one?
Refraction.
Refraction. The only one is left. The only one that is left. So let's see who's sending messages. Teams get you out. What do you mean by this? So let's go to the next one. And let's go Tamim, Nashmi. Read that, Tamim, read this one.
Yes. Max and Jimmy want to jump on a trampoline. Max begins jumping in a steady pattern, making small waves in the trampoline. Jimmy starts jumping on the trampoline too. Suddenly, Max goes twice as high even though he did not put any extra effort into jumping. What type of wave interaction is this? Explain how it occurred.
So we want to type the wave interaction is this. What this one would be? Do you know the answer? Is it reflection, refraction? What is it?
Standing waves.
Refraction. Bravo, Alec. This is, we call it a standing because you have what? But we don't, it's a type of standing. What exactly we call it? When you have to rise something by exerting an external force. You remember the swing? You remember the swing? What we called it? The swing was increasing the amplitude. He increased the amplitude here by an external force. What did we call this phenomenon? It will create, yes, standing wave, but what we call this phenomenon? When you increase the amplitude of a wave by exerting a force from outside the system.
Can I, Khalid Isa?
Yes, Khalid?
Mr. Is it resonance?
Yes, resonance. Bravo. Bravo,
Yeah.
Khalid, bravo. Yes. Resonance. So resonance is the answer for this question. Okay, resonance. So we want to complete the answer. This is the first part of the question. What type of wave interaction is that? This is resonance. Explain how it occurred. How it occurred. Tamim, can you answer the second part? How resonance occurs? I just explained it, by the way. How resonance happen? How does resonance happen, guys?
When
Anybody
external
knows?
conditions
Yes.
match the object's
You can. Tamim, when you answer, don't try to memorize words from the book. Just memorize or try to speak your mind. This means just saying what you understand it in your own language. Okay? Don't try to memorize the exact words that you have read it before. So, if you understand something, just say it in your own words, and it's right. It's not wrong. So say it again. Increasing what by what? It's easy. Increasing, huh?
the amplitude
The amplitude by what? By exerting and what? External
vibration
force or vibration force that matches the frequency, the original frequency of the vibrating object. That matches must be in a period of time that matches the frequency, the original frequency of the vibrating object, the original frequency of the vibrating object. That's the answer. So resonance increasing the amplitude. Resonance, it means increasing the amplitude by exerting an external force that matches the original frequency of the vibrating object. So you have to exert a small external one or a force, external force, with periods of time that matches the frequency of the vibrating object. So that's the answer for this question. I want you to read it again.
resonance increasing the amplitudes by exerting an external force that matches the original frequency of the vibrating object.
Bravo, Alec. Thank you. That's the answer for this question. Let's pick another one. Abdurrahman Milham. Abdurrahman.
Yes, teacher.
Read this question.
Max and Jimmy contain jumping on a trampoline. When they jump at the same time, Max makes a wave crease and Jimmy makes a wave through.
Trough.
I made a wave tough.
Trough.
What type of wave into? I can't see the screen. I can't see the other two words.
What type of wave interaction occurred? This is the rest of the question.
Destructive.
Bravo, it's destructive because Max makes a crest while Jimmy makes a trough. They make opposite things. And I said before, when crest meets with a trough, that is a destructive interference. Thank you, Abdurrahman. And let's see, Abdullah Nasser Milham. Abdullah Nasser with us. Abdullah Nasser Milham. This is not on the book, but this is topic 8, lesson 2, waves interaction Rakam. Okay. Abdullah Nasser is not here, absent. Laith. Yeah, Laith.
Mister, can you go to the previous question so I can take a screenshot of it?
Yes, I can. Laith, I can't hear you. Are you talking? I can't hear you. Yes, I hear you right now. Get closer to the mic. Get closer to the mic.
Okay. Mister, but before that, I'm going to ask you a question.
You want, Tamim, you want this question or the previous one?
No, it's all good now. Thank you.
Okay. Laith, what did you say?
Organization. This recording session, can you send it out to Sarah when
Yes,
you,
I will.
when we
I
finish?
will. I will.
Some kids are playing with a jump rope. They notice that they make transfer waves when they shake the rope up and down. They shake it quickly and notice that the wave platform appears to be holding still. What type of interaction wave is this?
What type of wave interaction is this?
Chef,
Yes?
for the quiz, if there is any quizzes, like, should we study for the quiz?
I can send you some quizzes. Later I will send you. But right now, let's focus on the revision. I will send you the video and the quizzes so you can practice both of them.
It's constructive inference.
No. Read the question again, Laith.
Some kids are playing.
Raise your voice, raise your voice.
Some kids are playing with a jump rope. They notice they can make transfer waves when they shake the rope up and down. They shake it quickly and notice that the waves formed appears holding still. What type of wave interaction is this?
What type of
Standing.
wave interaction is this?
Standing wave?
Yes, it's a standing wave because it appears to what? How did we know that? It appears to holding still. It doesn't appear to go to the right or to the left, and I said that about standing wave. It appears at is holding still or does not move to the left or to the right. Actually, we have two waves, incoming and reflected wave. So this is a standing wave. Thank you, Laith.
Mr. Abdullah Al-Hussein, can I go bathroom?
Yes, you're going to go. Cook tea. Rakan Rashid. Rakan. Rakan. Rakan Rashid, do you hear me?
Yes, teacher.
Okay, Rakan. Read this question.
Which one?
In front of you right now. Some students are investigating how resonance works using two tuning forks.
I can't read that word.
Rearrange.
Rearrange the steps of
Procedures
they should follow in correct order. Place the first step at the top and last step at the bottom.
Yes. So some students are investigating how resonance works using two tuning forks. Rearrange steps of the procedure. They should follow in the correct order. Place the first step in the top and the last step in the bottom, at the bottom. So, what's the first step? Read all the steps first.
The second turning fork will begin to vibrate at the same rate as the first one.
Read the
Hold
second choice.
the vibrating fork for right beside the other one. Strike one turning fork on the edge of table, making it vibrate.
So, what is the first step here? You want to make a resonance. So, to make a resonance, you need two things. You need a vibrating source and the force from outside that creates the resonance. So here we have a procedure that we have to follow and we have to rearrange it. So what one would you start? Would you start with this or this or this one? Which one is closest to you to start with?
The first one.
The first one, the second torque, this will be the top, at the top?
Yes, I think so.
The second torque will begin to vibrate. No, this is the first one because will begin to vibrate at the same rate as the first one. You just start with this. It comes from nowhere and just, there is nothing. You just say that the second one will vibrate. What happens before that? It's not the second, the first one.
Can I try maybe?
Let's give him a break, just to give him a chance to answer it, Ahmed. Then we'll come back to you. Strike one turning fork of the edge of the table to make it vibrate. Is this the first? You have this one or this one? One of these will be the first one.
Second one.
The second one. Hold the vibrating turning fork right beside each other. Turning fork on the edge of the table to make it vibrate. No, this is the first one. And this is the second one. And that's the arrangement. Okay?
Teacher,
Yes.
what does perpendicular mean?
Perpendicular means normal or at 90 degrees angle.
Okay.
عمودي يعني. Strike one turning fork of the edge of the table. This is the first thing to make it vibrate. Hold the vibrating turning forks right beside each other. After striking it, the second turning fork is going to vibrate the same rate as the first one, and that's how to create resonance. So this is a question just about, you know, it's about resonance. So let's go for other questions. And I think we will start from question 15. And question 15. Ahmed Al-Utaibi. I'll come to you, Ahmed Al-Utaibi, because you want to answer. And I didn't come to the bottom. Ahmed Al-Utaibi, answer this question. And not this one actually. This one, 15.
Yes. When a wave strikes a solid barrier, it behaves like a basketball hitting a backboard. This wave behavior is called just 1 minute. Refraction.
When a wave strikes a solid barrier, it behaves like a basketball hitting that. This is called what's all A, B, C, D? Which one?
C.
C, refraction. It bounces off, it bounces back, hitting a backboard like a basketball. A basketball will not make a refraction. Basketball will make what? It bounces off, bounces back in the same medium. This behavior called what? Not refraction, not C. When a wave bounces back or bounces off a surface, what we call it?
Reflection.
Reflection. D, reflection. We call it reflection, 15. So question 16. And let's go Abdulaziz Al-Nasr, Abdulaziz Badr Al-Nasr. Abdulaziz Badr Al-Nasr.
I'm here.
Okay, Abdulaziz, read question 16.
How does reflection differ from refraction and diffraction?
Yes. How does the reflection differ from refraction and diffraction? Read all the choices and pick up one.
Reflection is the only process in which the wave does not continue moving forward. Reflection is the only process that involves a change in the wave. Reflection affects all types of mechanical waves, but refraction and diffraction do not. Reflection is the only process that changes the direction of a wave.
So what's the right answer?
I think C, Mr.
Read it.
Reflection affects all type. No, D. Reflection
Read
is
it.
the only process that changes the direction of the wave.
So reflection changes the direction and refraction does not, and diffraction does not. Refraction also bends the wave. The definition of refraction, bending of a wave. And bending means changing the direction of a wave. You know, angle of refraction, you remember it? It will change the direction of a wave according to moving between two different media with different speed. So also refraction and diffraction also, both of them includes a change in the direction. But you have a different change in refraction, reflection, and diffraction. But all of them include changing the direction. Do you remember them? Do you remember the difference between this? If I come here and type reflection and refraction, and let's see that. You see this one? You see this images here? This is reflection. It changes the wave, and also in refraction, this one is refraction. If you see it here, won't open this one. This is when it reflected, it's in this direction. It changed direction, and also in refraction, it didn't continue in the same direction. It changed it, and in diffraction also it changes direction. If you see diffraction, you will see it go back to diffraction. It changes direction. So this is not the right answer. Reflection only process that changes direction. No, this is not right, because refraction and diffraction also includes a change in the direction of the wave. So what's the right answer? Not C, not D. عبد العزيز يا عبد العزيز
هلا مستر.
هلا والله. What's the right answer? What is the right answer يا عبد العزيز? You have only two choices. Choose from one from them. A and B. Which one is right?
I think A, Mr.
Yes, it's A, the right answer. Bravo عليك. That's it. Reflection is the only process in which the wave does not continue moving forward. Here, if you see that, wave here doesn't move forward. In the refraction and also diffraction, they move forward. They move forward. They didn't go backward. They didn't bounce off. So, bravo عليك عبد العزيز. It's the right answer, A. Thank you. Let's go for another one.
Teacher, how can we get this worksheet?
You can take it from the video, because it has a lot of other questions. It's not only for okay. This one. So let's take another one. محمد عبد الله العبود. محمد العبود. محمد العبود.
Yes, Mr.
Okay, Muhammad Al-Aboud. Answer the next question, question 17.
For refraction
To
occur in a wave, the wave must...
Yes, the wave must what? For refraction to occur in a wave, the wave must
strike on obstacle larger than the wavelength.
Read all the choices and choose one. Read all the choices and choose one. Read them loudly.
Change direction within a medium. Enter a new medium at an angle. Enter a new medium head on.
Yes, head on means perpendicular or normal. So what's the right answer here?
D.
D.
Wait.
If you fall perpendicular, you will not have refraction. If you fall perpendicular, if a light, for example, fall perpendicular between air and water, and it's head on, it means at right angle, it will not refract. It will go straight without refraction. That was one condition.
B. Change direction with a medium.
Change direction within a medium. In the same medium, it will change direction. For example, the light, while light is traveling through air, it will change only direction without any thing, just like this. This is the meaning of B. Change direction within a medium. Is this refraction? Refraction must include two different media. It can't happen in only one medium. It needs two media.
C. Enter a new medium at an angle.
Yes, this is C, Muhammad. The answer is C. Enter a new medium. As you see here, let me remind you. Here refraction, you see, to have refraction, this is refracted layer. You see this one, you see this one, that's it. It must move between two different media, as you see, at an angle. It falls, if it falls normal here, it will not refract. If it falls normal, it will not refract. It must fall on the separating surface between two different media at an angle. So refraction conditions are, you must have two different media, and the wave must fall at an angle at the surface separating between these two media, as you see here. Because if it falls at right angle, it will not refract. It will not refract. And also, if it's zero parallel here to the surface, it will not refract too. So it must hit the separating surface at an angle. So the answer is enter a new medium at an angle. The answer is C. 17. 18. 18 18 18 18. سعد محمد سعد. سعد محمد سعد.
Yes.
Saad, read question 18 here.
In refraction, when a wave travels from one medium to another, it changes speed, stays instead. I think A, changes speed.
Bravo عليك. In refraction, when you move between the wave moves or travel between two different media, it changes direction and also changes what? Speed. Actually, changing direction is due to changing speeds. So, in refraction, and here is refraction, when you move from one medium to another, you change the light or the wave changes its direction because the difference in speeds between the two media. 19. Salim Muhammad Musa.
Yes, teacher, I was mute, yes.
Yes, read this one, 19.
Okay. What is one property of a wave that determines how much it will diffract when it encounters an obstacle?
What is one property of a wave? Oh, I hear an echo.
One property, teachers speak amplitude.
No, not amplitude.
Then see polarization.
We didn't
See.
take polarization at all.
D, wavelength.
So you are saying by chance or by luck?
No,
So it's
like,
D. It's D. It's D.
yeah. D.
So the answer is D. Because mute your mic. I said before that in diffraction it depends on the size of obstacle and also on the wavelength. When we talked about diffraction, I said diffraction will mainly depend on the wavelength of the wave and how it's related to the size of the obstacle. And I said the best diffraction, I said that the best diffraction will happen when the obstacle size equal to the wavelength of the wave that's passing by this obstacle or by this gap. So the size of the gap or the size of the obstacle must, or you will have the best diffraction when they are equal in the size to the wavelength and their dimensions. So it depends, diffraction depends mainly on the wavelength. What is one property of wave that determines how much it will diffract when it encounters an obstacle? Its wavelength. This is the main thing that determines the diffraction. Question 20. And let's go for Turkey. Turkey Dahilan. Turkey. Turkey. Turkey absent. Muhammad Yasser. Muhammad Yasser.
Yes, mister.
Muhammad Yasser, read this question 20.
Which wave will probably be diffracted the most by an obstacle?
Yes.
C.
The wave with the longest wavelength. So the wave with the longest wavelength, yes, will do that with the longest wavelength, because it said all of this talking about different probabilities, and this only one that is talking about wavelength. So the answer is C. Thank you, Muhammad. Man al-Bishri.
Yes.
Question 21.
Suppose two waves collide and the temporary combined wave that results is smaller than the original waves. What term best describes this interaction?
Yes.
Destructive interference.
Bravo عليك. This is
Destructive.
destructive interference because it produces a smaller smaller wave than the original ones. So that is destructive. Why is that? Because the results is smaller than the original. Smaller means destructive interference. Thank you, man. Khalid Raisa. Okay, I'll come back to you, Ali. Khalid Raisa. Khalid. Khalid. Khalid, he answered me in the first of the session. Khalid. يا خالد. فيصل. فيصل.
Yes, teacher.
Faisal, would you read question 22?
Yeah, Mr. The formation of a standing wave requires A. The traveling of a wave for a long distance. B. Constructive inference between two waves of slightly different frequencies. C. That refraction and diffraction occur at the same time in wave.
What is that answer?
It's B.
No. We say the conditions for a standing wave, you must have what and what. B says constructive interference between two waves slightly different in frequencies. We never mentioned that we have two waves different in frequencies. We didn't say that. And we also have destructive interference in the standing wave, in the nodes, at nodes. If you remember, we have nodes which have destructive interference, and we have antinodes which have constructive interference. So in the standing wave, we have constructive and destructive. So it's not B. And we don't have a difference in frequencies between the two waves that are interfering in the standing wave. So it's not B. Do you know the answer? Faisal.
Yes, teacher.
Try to find another one. Read all of them carefully and find the answer. Faisal, let's maybe pick another one. Dawood. Dawood. Ali Al-Gannas.
Yes.
Ali Al-Gannas, can you solve this question? 22.
The formation of a standing wave requires the traveling. I think A.
No, not A. Standing wave, guys, I said there are what and what. The answer is here.
Oh, refraction and diffraction.
No, it requires interference between what and what.
Two waves.
Faisal.
B, I think.
No, not B. So Ahmed Abdelrazak, let's take Ahmed Abdelrazak. Ahmed Abdelrazak. Ahmed, do you know the answer for this question, 22?
The formation of a standing wave requires B.
Huh?
Which is answers B.
Read it.
That refractions and diffraction occurred at the same time.
The refraction and diffraction. C? No, this is not the right answer. This is not the right answer. Let me pick someone else. Abdullah Saad Al-Husseini. Abdullah Khalid Al-Husseini.
Yes.
Abdullah, do you know the answer for this question?
The formation of standing.
I said it's D, yes, but we have I've said all the answers, guys, but I said before, let me open for you. You have heat, gases, motion. I think that you have waves. What is waves? That's it, waves. I explained to you that in the standing wave we have, let me see, where is it? Not this one, it's not here. But in your book, let me open it for you. In your own book, you have what? You have two waves. One is falling wave and one is reflected wave. Let me find it quickly on here. Standing waves. So in the standing waves, I said there are two waves. One is falling and one is reflected. The source that's causing it, I want the image in the book, but it's not here too. But in the book, I said that we have a source of the wave that goes and falls and back again. In the standing wave, if you remember, with the man that we looked at it, we said that we have two waves, falling wave and reflected wave. Let me just open YouTube. And that's it.
Mister, the session ended.
Yes, I want just to show you something. That's it. If you remember that video, you will leave right now. Immediately will leave. That's it. If you remember this video, we have a frequency here that produces a wave. The wave falls. We call it falling wave and reflected on itself. So we have two waves. One is falling or incoming wave and reflected wave. If you remember that video, and it also exists in your book. So we have a reflected in the standing wave. We have incoming wave and reflected wave. Thank you guys for listening and see you tomorrow on the exam, inshallah. So the answer was D for this question.